I waste all my answers all day. Why? You confused me with the bit.
I told you not to listen to them.
She said it was. Well, you never say, okay, no, it's not that. You just like let me wonder, and I didn't know.
That's why I said don't listen to them.
Oh my gosh! Can I just?
All right. So I accidentally erased everything we did yesterday. So you don't have to. I hit don't save. So yesterday we were talking about metallic bonding, right? We had a chart going. So yesterday, under metallic, we said the electrons do what under a metallic bond? They move. So when you're taking the test on Friday, anything that asks you about a metallic bond, you need to pick an answer that says the electrons are moving or the electrons are mobile. So what kind of properties go with that based on our discussion from yesterday? What kind of things go with metallic bonding that we wrote down you need to know for Friday? All right. Metals are good conductors. All right. What else?
Malleable.
They're malleable. What did that word mean, malleable? Rolled into sheets. An example that I gave you that you all have at home is aluminum foil. Okay? Ductile. What did the word ductile mean? Drawn into wire. So if you have a gold necklace or a silver necklace, or if you think of copper wire, those types of elements are ductile. Metals are lustrous. And we talked about metals having the strongest what? The strongest bond. And because they have the strongest bond, what is that going to equate to today for our last topic? They have the highest what? That's right. They have the highest boiling point. Now, that's just a quick synopsis of what we did yesterday with metallic. Everybody okay with that? All right. Now, from there, we talked about an ionic bond, and then I drew some really ugly pictures, and I didn't quite finish with that yesterday, so we need to go back and talk about lattice energy. Now, from there, we said an ionic bond, the electrons are, but the key to being the difference between an ionic bond and a metallic bond, here, metallic electrons are moving or mobile, right? What can you tell me about the electrons in an ionic bond? They're what, Hema? They're locked into place, okay? I'm just reviewing with where we were yesterday. If you wrote this down, you don't have to write it down again. Okay, the electrons are locked into place. They can't move. So I said yesterday there were how many different crystal structures for an ionic bond? 7. Because remember, these are going to be crystals. I even asked if any of you made crystals, maybe in elementary school. A lot of elementary school teachers will try to grow crystals with elementary school students. Do any of you all get to do that? Okay, some people do get to do it, not a lot, but the whole column wrong? It'll be -5 for each of them. So -25. Or was it 6? How many questions were there? So there's 30 points. You might not have got them all wrong, though. Doesn't mean they were all right. It might have been, some of them might have been wrong. Some might have been right. All right. Now, if they were all crystals, I told you there were 7 crystal structures, and I tried to draw a cube. Now, granted, it was a pretty lousy looking cube yesterday. All right. But I drew one, and I told you I couldn't draw 3-dimensionally, and I still can't draw 3-dimensionally today. I can draw one cube. I can't draw a bunch of cubes. All right. So this whole thing was supposed to be my crystal lattice, right? And my crystal lattice showed a whole bunch of crystals. And then inside my crystal lattice, I showed one crystal, and this one crystal was called a what? It was called a unit cell. All right, the unit cell was one crystal. Now, beyond that, I have absolutely no idea how far we got. I know I said that these were Brittle. I know we said because they're brittle, they're not malleable. All right, they're not ductile. They're not conductors. And that's all because the electrons are not moving. They're all locked into place. Now, I know we wrote the word lattice energy. Did I get any further than that? No. No. All right. So we talked about this being the strength of the bond being sort of the middle one because we said covalent was the weakest. But these are much closer to metallic in terms of strength. Now, lattice energy is where I needed to go today because lattice energy talks about the strength of the bond. Okay? Lattice energy is the energy needed to break the bond in a crystal. So, the higher the lattice energy, the what? What can you tell me about the strength of the bond based on the lattice energy? What? It would increase the what? Okay. So the higher the lattice energy, the stronger the bond or the weaker the bond? That's right. The stronger the bond. I don't remember if I actually wrote down any numbers for this. But I can look some up real quick so I'm not just making up junk. I've got some real numbers.
I can't think it.
Usually they have charts of this. I have a chart. I don't need pictures of it, I need charts. Let's try that again. Yeah. I can't hear you. Yep. Oh, did you still need a Bryce? Did you? Were you done?
Yeah.
Okay.
Everybody tells me I do.
It's your birthday.
I'm going to play real card because I just like
Friday. Oh, I see, man.
inches. What's on? You probably talking about inches, man. Huh? Well, Quavo?
Oh, my God.
All right. So if we look at these lattice energies, I looked some up so I didn't make up a bunch of junk. All right, these are all kilojoules per mole. Now, if you look at those, you should be able to tell me who's the strongest and who's the weakest of the crystals. All right, who would be the strongest and who would be the weakest? All right, who is the absolute weakest of all these crystals? Who would be the easiest crystal to melt out of those four? Sodium bromide. Okay? This one would have the weakest bond, so it would have the lowest melting point and boiling point out of the four. So, by the same argument, who would be the strongest? It would have the highest melting point and boiling point. SCN, that's scandium nitride. So, this one would be the strongest. So, it would have the highest melting point and boiling point based on those lattice energies. Questions? Any issues with that concept? That's just for honor. Okay? Now, the last thing I want to talk about with ionic is there any way to make an ionic compound conduct? Can we make it conduct? The electrons are locked into place. So theoretically, if we can make the electrons move, we can do what? We can do what, Emma? If we can make it move, we can make it do what? Make it conduct. So can we get the electrons to move? How? What can we do? Hyro, shush, because you're not contributing. How can we get them to conduct? Exactly. Okay? Now, this is still all under ionic. Yes, you're supposed to write this, guys. Yep. It gets a little loud with the flushing the toilet there, but I can hear y'all at the moment.
Because it sounds like it's getting louder.
It does. How can we get ionic compounds to conduct? One of the ways that you can do that is to melt it. All right. We usually refer to that as the molten state. So if you take salt and melt it, for example, into a liquid, then the electrons would be able to move. Now, I don't have anything here that will allow us to heat salt to 800 and some degrees, so I can't melt salt in this lab to be able to show you that. It just will not work. However, there is another way that we could get salt to conduct. What else could we do? There you go. We can simply dissolve it in water. Y'all do the same thing every summer when you get into a swimming pool. If you take any glass or a beaker and you dump some salt into it, what happens to the salt when you put it in there? It dissolves, right? Well, what happens when it dissolves? It breaks into sodium ions and chlorine ions. All right? These ions are the moving electrons. Those ions are the moving electrons. So, when you get into a swimming pool, what do we dump in by the bucketful? Chlorine. Same thing that's in salt right here. Kills germs. All right? If the lightning storm comes up in the summertime, what do you have to do? Get out, because those chlorine ions are moving electrons. If lightning strikes at one end of the pool, what's going to happen to that current? It's going to flow from one end all the way to the other end where you are. Okay? Same concept if an electrical current runs from one end of the pool and you're at the other end of the pool. Those chlorine ions carry the electrical current from one end to wherever you happen to be in the swimming pool. Chlorine is an ion. It's moving electrons. They carry the electrical current. There's no way to avoid it. It was what? Okay. I don't want to discount anything your mama said. However, For future reference, get out of the swimming
My
pool.
kids that. God, that's crazy. I could have died.
Get out of the swimming pool for future reference. Okay? Questions? All right. Now,
Hold on, I can't see.
Well, you said we're supposed to write down the number from the previous.
you don't have to necessarily have the numbers, but you need to understand that a higher lattice energy is going to have a higher melting point and boiling point. As long as you understand that, you're fine. The actual numbers, I'm never going to ask you the numbers. Put your phone up, ding-a-ling.
Show me a ding-a-ling.
Yes, I did.
What? I just think that's such a bloody word.
Put your phone up, Goofus. All right. So the last type we need to talk about is a covalent bond. All right, a covalent bond, we know the electrons are shared. Again, the electrons are locked into place. Now, the thing that makes these different from ionic is they will not form ions. So, if it will not make an ion in any shape, form, or fashion, can we get these to conduct in any way? No. Okay, so it doesn't matter what we do to a covalent bond. All right, it will not conduct. We cannot make these conduct. They are not, let's say this, because they are the weakest bond, they have the lowest melting points and boiling points. They are often liquids and gases. All right, they have the lowest melting points and boiling points, and they're often liquids and gases. Now, if we go back to onyx for just a second, I said onyx was often a what? It was a crystal. Now, I just assume when I say it's a crystal, you know what state a crystal is. What state's a crystal? Okay, let's just making sure we were all together there. All right, but covalent compounds tend to be liquids and gases. There are solids. They're not all going to be liquids and gases, but a lot of them are liquids and gases. All right, these are often said to be volatile. Now, it's a new vocabulary word for us. Volatile means it evaporates easily. The best examples I can give you of those are alcohol or nail polish remover. Okay? All of you have been to the doctor or you've had a cut or something and you've rubbed some alcohol on your skin. How long does it take alcohol to dry on your skin? Not that long. Okay? It's very quick. Any of you who've had your nails done or had to have nail polish taken off your skin or your nails, acetone, a drop, it is gone. If you've ever bought one of the sponge kind of nail polish remover and you accidentally leave the lid off and you come back to it, that sponge is dry in less than 30 minutes, okay? It is very volatile. It evaporates very, very quickly, okay? Trying to think if there's anything else I want to say about that one.
What about carbon dioxide?
What about it?
What is it?
It's a covalent compound. It's a gas.
It's a gas?
Mhm.
That's why it's like on your way to.
Carbon dioxide. Now, you can change it into a liquid. In its natural state at room temperature, it's a gas, okay? It's the gas we exhale. But if you put it in a pressurized cylinder and you increase the amount of pressure on it, you can change the gas into a liquid. All right, so when you think about carbon dioxide in like soft drinks, we put it in a pressurized cylinder and we lower the temperature and we increase the pressure on it so we can change it into a liquid so we can get more of it in the cylinder and it will last longer. Okay? All right, questions?
What about plasma?
What about what?
Plasma.
Plasma is a different state of matter. The best examples I can give you of that are like the sun and the stars. And it's really not part of our content. So I won't spend any time talking about it the entire semester. All right, the last topic we need to talk about are van der Waals forces.
That was all for covalent?
That's it.
That's Victor.
So there's no more at all?
Nope, we're done with the chart. This is it. Huh? All right. The last thing we're going to talk about today is van der Waals forces. And I will tell you, this topic is really, really oversimplified. Those of you who will one day have to take a college chemistry class for whatever degree you're getting your bachelor's in, if you have a college chemistry professor who teaches this really well, they'd be appalled that I'm simplifying it this way. But you really don't have to know all that you need to know for this, so I'm drastically oversimplifying it.
Will this be required for first year?
In a first-year chemistry class?
Well, no, like taking like a chemistry, like
Probably.
chemistry focus, like so like
Probably.
or math focus. We have to take like this class.
It depends. Most liberal arts schools, if you're majoring in math, probably require a science. It may not be a chemistry science. For example, I majored in chemistry, but I only had to have a biology class. It didn't even require a lab. So I only took one semester of biology, and it didn't even require lab science. But I had to have 2 semesters of of physics, and it had to be physics with calculus. So it just sort of depends. What?
Is that OA or AA?
AA. All right, now, van der Waals forces, all right, are first of all forces of attraction. So I want you to think of these as like magnets, okay? Because they're not bonds. They're not permanently attached to each other. They're just attractions, all right? Now, these are also between covalent molecules. So these also do not apply to ionic or metallic bonds. These are only going to apply to covalent molecules, and it is only going to be an attraction. So water molecules, for example, will have van der Waals forces. It's one of the reasons why y'all talked about adhesion and cohesion in biology classes. They had van der Waals forces. Now, there are 3 types of van der Waals forces. The first one we're going to talk about is called a dipole force. All right, a dipole force is an attraction between polar molecules. So, in order to figure out if something has a dipole force, we have to figure out if it's what? In order to figure out if something has a dipole force, we have to figure out if it's what? Polar. Okay? We will have to figure out if it's covalent first, yes, but we will have to know if it's polar to know if it has dipole. The second type is called hydrogen bonding. I have no idea why they decided to call it hydrogen bonding because, again, it's not a bond. All right, it's an attraction between hydrogen and a lone pair of electrons. So in order to know if you have this, you have to draw the what? Yes, because it's easy to see if you have a hydrogen, but how are you going to know if you have a lone pair of electrons if you don't draw it? So we got to have a hydrogen and we got to have a lone pair to have hydrogen bonding. And the last thing we will have is called London dispersion forces. Okay, London dispersion forces. This is an attraction between non-polar molecules. Now, the only other thing we need to know is who's the strongest, so we know who's going to have the highest and lowest boiling points. So catch up with me, and we'll talk about who's going to have the highest and lowest boiling points. In college, probably organic chemistry, which is most people's worst, or they hated it. I like calculus a lot too.
You like calculus?
Oh.
I did 1, 2, and 3.
You can do it too.
It's been 25 plus years.
But you probably, if you went there, you could do it.
I minored in math. I probably should have majored in it, but I didn't.
You should have doing like calculus.
Yes.
It's been 25 plus years. It's been a long time.
You should have referred
Huh?
You should have went to calculus.
If I knew then what I know now, I might have been a math teacher, but I did not plan to teach.
What did you want to do?
Oh, that's why I got a chemistry degree. I was only teaching for 4 years to work my scholarship off, and then I was getting out of education.
I was saying.
I actually liked it. Huh? UNCG. I didn't plan to teach. That was not my goal. I got a teaching scholarship because it was a full ride. All right, we caught up? All right, so out of these three, which one of those will be the strongest?
First one.
Most people think that.
The third.
No.
The second one.
The second one is the strongest. That's why water has such great forces with adhesion and cohesion. Hydrogen bonding, water has a hydrogen and a lone pair. Okay? So hydrogen bonding is the strongest. All right? So anything that's the strongest is going to wind up with the highest boiling point. So anything that has hydrogen bonding out of these three is going to have the highest boiling point. Who do you think would be the weakest? The one that has the polar molecules or the non-polar molecules? Non-polar. Non-polar molecules are weaker. So these will be weakest, and these will have the lowest boiling points. That means if you have dipole-dipole forces, you're the one that'll be in the middle. Okay? All right, are we caught up? Everybody got the notes so we can apply? All right, everybody got it? All right, so what are you going to have to do with this in first response? Rank the following. In order of increasing boiling point. And let's say that we have nickel, we have CCl4, we have water, we have NaCl. 1, 2, 3, 4, and we have SO2. Yeah, that ought to work. Yes. So if we're doing increasing blown point, we're starting where and we're going where? We're starting at the lowest and we're going to the highest. Based on our discussion yesterday and today, what should I look at first? What's the first thing I should look at?
What type of bond?
What type of bond it is. All right, so what is Ni? It's a metal. Okay, so if it's a metal, it has what kind of bond? All right, so this one has a metallic bond. All right, CCl4. All right, now we've said metallic, ionic, and covalent. Clearly, it's one of the three. How would we narrow this down on Friday?
Yeah, it has two. Wait, no, it has
I am
two
so
items.
moving to Montana and becoming an alpaca farmer. Y'all need to start looking for some land and alpacas for me.
What did we call that?
How do we decide? I got some folks going, it's clearly ionic, Ms. Wall, and some of y'all go clearly covalent. We can use electronegativity, which is fine. There's nothing wrong with that method. And we can do what else? Okay, some folks said, Ms. Wall, it's a metal and a non-metal. How do we decide if it's a metal and non-metal? Where's carbon up there? It's in yellow, right?
Hey,
Is that a metal?
No.
I said it had two non-metals.
Yes, I know, you did, but some people did not. Chlorine is a what color up there? They're both in yellow, so that makes them both what? Covalent, okay? Or you could have done what Betsy said. You could look up the electronegativities. I think it's 2.5 and 3, so when you subtract, you get 0.5, and 0.5 makes it polar covalent, okay? But either way, it's covalent. Everybody okay on how we got covalent? Okay, so what can you tell me about water? All right, I hear more people saying covalent that time, but still there's only like 4 little tiny voices out there. Yeah, I gave you the answer. All right, what about NaCl? That was a little stronger. All right, what about SO2? All right, so what do we know based on our discussion yesterday and at the start of our lesson today for review? What type of bond do we say was the strongest and going to have the highest bond point? Okay. That was a little stronger. I was not quite as pathetic and weak. All right, so metallic was the strongest. And then who was next? And then who was the weakest? All right. So I know nickel is down here. And I know NaCl is here. And I know CCl4, H2O, and SO2 are here. But that's as far as I can get just using that, right? So how are we going to figure out CCl4, H2O, and SO2?
Wasn't that not involved with Van der Waal?
There you go. Now we got to fall back on Van der Waal. So that's okay. That's okay. We're in the ballpark. How are we going to know which one it has? How do we know if it's got dipole-dipole or hydrogen bonding or London dispersion?
Yes, if it's polar and non-polar.
Exactly. We got to figure out who's polar and non-polar. So how do we figure out who's polar and who's non-polar? Okay. So we got to draw the Lewis structures. We cannot just subtract electronegativities. It will not work.
All this on the test.
All this is on the test. Infer response.
Can't you just look at the H2O thing and just know that it's hydrogen bonding?
No, because for example, CH4, you would say it's hydrogen bonding and has no lone pairs. So you have to draw to see if it's got lone pairs. All right, so I drew the three Lewis structures for us. Okay? So if I draw the Lewis structures, what can you tell me about CCl4? For those of us who mucked this up on the quiz. How do you decide? How'd y'all say? Nonpolar as well. Okay, so what can you tell me about all the dipoles? All the dipoles are equal. Lone pairs? So, non-polar, very good. All right, what can you tell me about all the dipoles on this one? They're equal. What about the lone pairs? We've got two of them. So that tells me what about water? All right, and what about SO2 over here? Are the dipoles equal? Are the lone pairs? So that tells me what? All right, so using our rules, anybody who is polar has what kind of? All right, so that means I got two that are labeled dipole over here. This one has dipole, and dipole. The one that has nonpolar, I'm just going to write LDF instead of writing out London dispersion. And does anybody have hydrogen bonding? Have a hydrogen and a lone pair? Anybody have a hydrogen and a lone pair? This one has a hydrogen and has a lone pair, so that has hydrogen bonding. All right, so who's the strongest up here? H2O. Who's the next strongest up here? And who's the weakest up here? All right, so now I need to put those in my answer. So if I come back over here, I got H2O, SO2, CCl4. Questions about how we did that? You think you can try one?
No.
Why not?
Yes, no, baby.
Can you see how far you can get and then we'll do it together? Same question. Same ranking. Smallest to biggest. I'll just change the elements or compounds. All right, let's do NH3. Let's do CH4. Let's do Fe. Let's do KBr. And let's do PCl3. Right. Put those 5 in order. Same question. Smallest to largest.
Iced tea.
Why did you pour down the sink?
Because if I take the lid off and pour it down there and turn the water on, y'all are going to sink station. Start hooting and hollering, so it's not worth it. It's worth almost peeing on my pants. No, just the front too. You can't figure out the type of bonds. At least people get that far.
A lot of.
What's a non-metal and metal? Any ideas? Come back.
Where's FP?
It's between six. Then cobalt.
Metallic, just totally.
Oh, come from the ornament wall.
Say what? I can't hear you, Devin.
Hey, I put them in order.
Sure. After everybody's got a chance to do it, give it a little longer. Can be, each of you guys, sure. But you're not metals, is basically what you're looking for. Doesn't have to necessarily be metals.
Oh, it's right
What you
there.
got?
I just noticed.
The only problem you guys is back that you went from highest to lowest. I said do the same order, lowest to highest. You gonna explain it or just stick the answer?
I mean, I'll explain it.
Oh, I would be fat, that would be most fabulous.
Yes. What was up on here? Then I gotta make up 2 more questions. I think I gotta make up 5 or something like that.
Yay.
Looks like I agree.
They don't come on.
It's okay.
You're not saying, I don't care if you got anything.
You don't care if I make a thing. I care if I make a damn thing.
There's spaces you can use.
Why are fourth breaks not popping up?
They just won't for a little bit, and I think they are now.
Yeah, they should be popping up.
My third
He
year
wants in
is
a
like
second.
like crazy. The breaks will not pop up.
Lost it yesterday.
Oh, she did?
Yeah. Went after I. Oh, bro. Oh, my green.
Everybody's swearing now.
I got it.
I think this was that.
It's law. It's law.
Yeah.
Do we have an assembly today?
I don't know. Are they doing the junior class today?
Because yesterday they did this.
Oh, bro, how about we gotta.
I know they did the seniors yesterday. It's possible they're doing the juniors today.
Huh?
I haven't been paying attention, so I can't swear to it.
I hope it's their enforcement. Yes.
I wasn't listening, so I don't know.
Oh, I hate Asian people,
All right, Devin, put it up there.
Y'all my brothers, but you're not my brother.
Devin,
Okay. I got you.
you're Hispanic. Why are you on 44? You don't know the language?
No, he don't know Spanish. He don't know Spanish. He don't know Spanish.
Wait, did you not turn it work?
Right.
Yeah.
That's just, you don't have a right there. You got a 1 out of 100. Hey, you got a 1 out of 100. You have a typo. You need to ask about that. You got a missing grade and a 1 out of 100.
Hey, why you letting her grill you like that, bro? Huh? Huh?
right,
No.
so, let Tevin explain and then I'll fill in the pieces.
I was about to say,
All right, let him explain.
yo, but,
Yeah, lowest highest.
my left, you're right.
Huh, what?
My left, you're right. Oh, cause like he said, like, cause I'm trying. Anyway, I did this going lowest to highest. Huh? All right. How is Fe? That's iron. That's a metal. KBr. K is potassium. That's a metal. Bromine is a.
Sit down. Good God.
I got it right.
All
Just
right,
don't respect me.
what can he tell you about that? That's a metal. Everybody okay with that?
No, I don't know how he did that.
Can you say that this is a metal?
Yes.
Can you identify that Fe is a metal, Selma?
Yeah.
Okay, that's how you knew it was highest.
Starts off being
All right, which one of those is ionic up there?
Oh, you do this.
You can. All right, but you got to find the one that's ionic. That's next. All right, so this one is a metal and a non-metal, so it's ionic. That's how you knew that one went next. That's how you got metal and ionic. Okay? From there, these three are all covalent. From there, he has to draw the Lewis structures to figure out this one has hydrogen bonding.
I thought NH3 was on.
This one has dipole, and this one has LDF. That's what you're looking for. This one is ionic. Kevin, hush. And this one has metallic. That's the order you're looking for. The question is, which one has those things? And H3 has lone pairs on the end. So it's the one that has the hydrogen bonding because it has the lone pair and the H. PCl3 has lone pairs on the P, so it's polar. And CH4 has 4 H's, no lone pairs, and the dipoles are equal, so it's nonpolar. That's the one that's LDF because it's nonpolar. Okay, but anytime you put those in order, LDF will be the lowest, then dipole, then hydrogen bonding, then ionic, then metallic.
Every time you do this, you like come on.
This one, I'm very fast, but I forgot how to identify if it's ionic or covalent.
Ionic is a metal and a non-metal, or you can subtract, and it's got to fall between 4 and 1.7.
Don't be embarrassed.
I'm just gonna try to blame you.
You could do this, ionic, polar covalent, non-polar covalent. Anything that's 1.7 to 4 is ionic. Anything 1.7 and below is covalent. Or you could say metal and a non-metal is ionic. And anything down here would be 2 non-metals. You can do it either way. Either method works.
Miss Wall,
Yes, ma'am.
could you pick up for a moment, please?
Yes, ma'am. Sure. It's okay. That's fine. I'll do the first half if you want. Sure. Sure. You're welcome. Go ahead. All right, we got it? Any questions?
No,
Nope. All right. Up off the floor. All right, let's start homework. Now. I need to give you some instructions on tonight's homework because you are not going to know how to do it without some instructions. There are sections you will get stuck on. Tomorrow we will take about half of the period to review, not the entire class period.
Oh, yeah.
I gotta keep it.
What is she doing? If I check tomorrow, why don't we see if we can't do a little better than we did the last 2 days?
Don't check tomorrow. Yeah, please.
Just mine. All right, if you look at part 1 or part A, that one's pretty self-explanatory. You're just gonna go through and mark either I or C. Part B, if you will, mark out question 5 and 6. Question 5 and 6 are part of an ISO electronic series. It's not part of our curriculum, and I told you we wouldn't do it, and we're not going to. Part B, number 5 and number 6. All right, part C. No. In the first line, you need to draw a dot diagram. If you're not going to remember that, make a note. The first line, row, is a dot diagram. The second line, or row, is an ionic structure like we drew today in the opening, or like the equations that we drew in the opening, or we practiced yesterday, like Ca plus O.
You said a what? A line structure?
Like,
It's like the
it's an ionic structure like Ca plus O yields. You're going to draw some dots. This is how you do the first one. What happens in that first box for CaO? What happens to Ca? What Ca do with its two? It loses. So I write Ca and it does what? And then O does what? And it gains the 2 dots, so I draw 8 electrons there, right? That's how you do the first one on row 2. Now, the third row are just flat out Lewis structures. So write Lewis structure out to the side if you're not going to remember. The third row. Now, part 4, or D. A is the central atom. X is the atom, and E are the lone pairs. These are to help you practice with the geometries for those of you who left those blank on the quiz or don't know them. So if it says AX4, if A is the central atom and there are 4 atoms, what geometry are they trying to tell you that is? I heard Betsy say it. Tetrahedral. All right. On the back side, hold on. On the back side, E says bond polarity, so you're doing what? Electronegativities. And F says molecule polarity, so you're using the what?
I can't even remember.
You're using the what? The 2 rules. F, you're using the 2 rules, and in E, you're using the electronegativities. Try doing your homework tonight. Are the dipoles equal? And do you have lone pairs?